All right, good morning. Happy Wednesday. We're on that Wednesday schedule where we go to school all day, it seems like. I did mention the other day about I'm not accepting late work, so please don't text me about turning in things late unless there is some type of emergency, and I'm talking about something medical, some, you know, law thing that was going on, so a true emergency. Otherwise, I'm not accepting any late work. Also, late scratch paper, that's absolutely not accepted. I'm giving you plenty of time to take the exam and turn in the scratch paper, and you must turn it in on time or you're going to be getting a 0. I spent 12 hours on Sunday, I mentioned, trying to go through things, and it's just taking up my entire life, and I'm just not going to do it. So please fall in line with everybody else. If you're one of those people who habitually keep doing things late and wanting credit for it. Let's see here. I think that's all I want to say. Oh, the big problems that people are having with the internet and Wi-Fi is you must be using the Chrome browser. So let's say you have a brand new laptop, $1 million on it, and you're using Internet Explorer. That's the problem. So that's why I've been encouraging you to get a Chromebook and get a hotspot, because if you're using some other browser, that's part of the problem, if not the entire problem. So it doesn't matter how expensive a device you're using, you must be using Chrome. And if you're not using Chrome, that's what's causing the issues, because that's what the district's using, and there's a conflict. All right? Okay, if you need to know more about that, contact me. I started teaching 5.2 the other day, and I put you into the Math Wizard teams. I actually taught problems 1 through 54, and I was really disappointed in the way some of you are working in the teams. I do realize the teams are new and they will change periodically, but I'm trying to show you something. So please let me be the leader and don't take over. You know, I had so many students say, well, we're doing it this way. And, you know, we're doing it because it's the best way. And it's like, okay, well, thank you so much that you have a math credential, that you have a master's degree, that you've been teaching for 30 years, that you can just take over and do my job. Okay, so just let me tell you, you guys, I'm very capable of doing my job. Okay, I can do my job, just let me do it. Okay, and when I ask you to do something, like when I ask you to do the problems like I do it. Okay, there's everything that I say and do. Okay, if I ask you to, in the Math Wizard teams, work on the steps together, it's because I don't want to take a half an hour to do 7 problems. I want to do 7 problems in 15 minutes the way I'm saying to do it. So please fall in line. All right, play your role, play my role. Give it a chance. You know, it's funny because the people that are this system right now are the people that have D's and F's. The A students are the ones that are doing what I'm asking. So please, give, especially if your grade could be better, give me a chance. So before we get started, and I also, for those of you who are around, I assigned 40 problems in 4 days. That's 10 problems a day. So I have her, I am watching the number of problems I give you. So you should be able to do 10 problems a day. So, you know, do that. All right, anybody want to ask questions about problems 1 through 54? So I'm going to continue today. Any questions about problems 1 through 54? Questions? Problems 1 through 54?
Can you do problem 15?
Sure. I think I did this in class, maybe not. solve for y. So they want to know, is the equation, does it define y as a function of x? So solve for y. So when you solve for y, you get negative x squared plus 16, take the square root. Don't forget plus or minus. So y is equal to the square root of negative x plus 16. So this is square root, which has been reflected, oh, I'm sorry, left 16 and reflected over the y-axis. This is actually two graphs. It's the positive graph and it's the negative graph. That's what this means. If you do not know how to graph this, you could put it on the graphing calculator. So you could put this guy under y sub 1, and you could put this guy under y sub 2 and hit graph. And what you're going to get is you're going to get something that looks like a circle. But because you have a rectangular viewing window, you have to square it up. It kind of looks like an ellipse, but regardless, it does not pass the vertical line test. So this is not a function. So this is not a function. It does not pass the vertical line test. So if you know how to graph square roots, which you should know how to graph by now, this right here, this not only reflects over the y-axis, it reflects over the x-axis. So that's what makes the circle. So you can either do it by hand or you can put these two in the graphing calculator. But it's not a function, it's a circle. For those of you who had me before, I said that when these numbers right here are the same and you have x squared and y squared, it's definitely a circle. Okay, anything else?
Can you do question 54?
54. They gave you two functions. They give you a parent, f of x is equal to square root of x. It's the most basic graph, and square root looks like this. You can look at that parent sheet that I gave you. They're giving you g of x, which is square root of x plus 2, and they want to know what is g doing to the parent. So you can say right away by looking at this that g of x is shifting or translating the parent or moving the parent two units left, or f of x left 2 units. So they want to know what it's doing. It's moving f of x 2 units left, right? Minus 2, minus the negative 2. And then they want you to make a table, which we're not going to do. And then they want us to graph both. So right now, we're not doing transformations like we did in the practice that I gave you. All we're doing is translations, which just moves the parent left, right, up, or down. So the parent, the points for the parent, if you put in a 0, square root of 0 is 0. If you put in a 1, the square root of 1 is 1. So 0, 0, right 1, up 1, and you draw the graph to the right. That is f of x. That is the parent of square root. Now, all you have to do is move the graph 2 units to the left. So you take this point and move it 2 units left. You take that point and move it 2 units left and just graph it. So you don't even need to write the transformational points. Just move the points 2 units left. That's it. Don't make it hard. So if this 2 is outside, you would have moved it up. If this was x minus 2, you would have moved it 2 units right. If this had been -2 on the outside, you would have moved the black graph 2 units down. That's it. It's like taking your hand and moving it without changing the graph. You're just moving the graph. That's a translation. Please unmute yourself and tell me, do you understand what I'm saying here?
Yes, I understand.
Okay, anybody else? Okay, I want to know, are we all lost or do you guys get what I'm saying?
Ms. Birch.
Yeah.
Okay, what is the main key of knowing when you're translating or not? Like, what's the main key of like, okay, this is when you're translating, you know?
H and K. H and K.
Okay.
So if you have H or K, you are translating, you're
Okay.
moving.
Yeah.
Because H moves things left and right and K moves things up and down. So those are the two letters. When H, you know where H is, right? It's in here and K is outside.
Yeah.
So H and K are translators. They just move a graph. They don't change the morph or change the shape of a graph. And if you're confused about that and you want to show the transformational points, you would just say left 2 is the X. So left 2, and the Y stay the same. And look what I have, left 2, 0, left 1, up 1. That's exactly what I have graphed. Now remember that assignment where we did like 20 problems? Remember when I had you state the transformation in the correct order, show the transformational points and graph? Those of you who did that assignment, you know exactly what I'm talking about. Those of you who didn't are probably the ones that are having trouble. So you better watch that video. It's the video on transformations. I spent a whole day doing it. If you do not learn how to do this, you're going to have to make tables all the time. And there are no students that I know of from pre-calculus on that make tables. They all know how to do these transformations. And this is going to get worse. This isn't going to go away. You're going to have to do harder ones that have, see, this is just one little step. You're going to have to put this together with 3 or 4 steps. So it's going to get more and more complicated. So you have to know how to do this now. Okay, remember I gave you the quadratic form? Well, here's the square root form. It's a times the square root of bx minus h plus k. It looks exactly like the quadratic, but it's square root. Doesn't this look exactly like the quadratic? But it's square root. A, vertical stretches and compressions reflect over the x-axis. B, horizontal stretches and compressions, reflection over the y-axis. H, left and right. K, up and down. Where is this? This is H, right? And isn't this in the form written as x minus a -2, which is why we went left 2 to write it in. Okay, other questions? Okay, what we're going to do right now is we're going to look at have your books open on page 176. And I'm going to give you a problem and you're going to tell me if it's a function or not. Okay, what is a function, guys? Somebody unmute. What's a function? Give me 2 ways that you know that you have a function or not. What are the 2 ways?
What number again?
I'm asking, how do you know the 2 ways that you know you have a function?
If the x's don't repeat.
Exactly. If you have a relation and the x's don't repeat, like when you have sets, right? A set of ordered pairs. That's one of the reasons. What's the other way you can tell if a graph is a function or not?
when it's like a line, or when a parabola reflects
You're right.
y over the
You're
x-axis?
right. But what kind of test do you use to
Oh,
tell if it's a function or not?
The vertical line test.
That's right.
yeah, yeah.
So when you hold up your pencil like this, long pencil, forever up and down. If it only passes through your pencil once, it's a function. Remember?
Yeah.
All right, so tell me, number 56. I assign the odds in your assignment evens right now. Is number 56 a function or not? Page 176.
It is.
It absolutely is. Good job. 58, is that a function or not?
No.
Fails everywhere, right? So that vertical line fails the vertical line test everywhere. All the x's are repeated. One up one, right one up three, right one up seven, right one up nine, right one up. It's a big mess. All right, number 60. Is
No.
that ellipse a function?
No.
Sorry, absolutely not. Number 62, is that side? We know that an upward parabola is a function. We know a downward parabola is a function. Is that a function?
No.
Absolutely not. Number 64, that's a weird graph. We don't have a parent that looks like that, but is it a function though?
No, because it's not passing. It's not passing through the line yet.
Hold on a second. When you hold up your pencil, does it pass the vertical line test?
No.
Number 64?
Wait, how?
64 doesn't pass the vertical line test?
It's a function.
It's a function.
Yeah, but how?
Be- Does that pass the vertical line test? Yes. Does that pass the vertical line
Oh,
test?
yeah,
Yes.
yeah,
Does
yeah.
that pass the vertical line test? Yes. Does that pass the vertical line test? Yes. Does that pass the vertical line test? Yes. Does that pass the vertical line test? Does it forever pass the vertical line test right and left?
Yeah.
Yes, it does. It's a function. Do you understand or no?
Yeah.
Okay. Now, I'm going to draw a graph up here. Because in the first part of the lesson, remember when you evaluated, when you put in an X, you got a Y? Remember when you put in a 1 and you got a Y out? Check this out. I'm going to draw, this is my example. You get a marker that works. Now, you don't have an equation that says parent, that this is, we don't have a parent for this one, right? But is this a function? Does this pass the vertical line test?
Yeah.
Yeah.
Yes, it does. So this is a function. It's weird, but it's a function, right? This is X and Y. So check this out. If I asked you to evaluate f of -2, what do you suppose you're going to do? What am I giving you? Am I an X or a Y or both?
Is it both?
Yeah, I'm going to change this. Yep. I'm going to change this -3. Actually, I'm going to change it to 1. Sorry. So here we go. What's X?
1.
Right. What's Y? F of -1, right? So I'm going to ask you again. Please participate. What's X?
1.
What's Y?
-1.
F of 1.
F of 1. Let's do it again. What's X?
1.
What's Y?
F of 1.
F of 1.
Uh-huh. What are we gonna do? We're gonna look at 1 and give the Y value. Okay, so when X is 1, what's Y?
F of 1.
It is.
Mm-hmm.
And what else is Y? Look at the graph.
-1.
No, it's positive 1.
Why would we pop, bro? Oh my.
Bernie, isn't this what's Y? What's X?
2.
What's Y?
F of 2.
Yep. And when you look over here, what is also Y?
2. Oh, it's 1.
That's a
Never mind.
2?
Whoops, one bad. No, it's 1. It's 1. Never mind.
It's okay. It's okay. Here we go. I'm going to do a bunch so y'all get it. F of 4. What's X?
4.
What's Y?
F of 4.
What is another Y that you can see here?
Just 1.
What's X?
-1.
What's Y?
F of -1.
And what is also Y with the graph? When X is -1, what's Y?
I don't know, what, -3? Or would it be 3? Because it's, oh, okay.
Is this a -3 or a 3? I thought 3 was up here and negatives are down here.
It's a -3.
Right. Okay, let's do another one. What's F of -3? Okay, well, what's X?
-3.
Right. What's Y?
F of -3.
Right. And what's a Y when you look at the graph? When X is -3, what's Y?
-1.
Do you guys get this or no?
Yeah, it's pretty simple.
That's right. Do y'all get it? Okay, well, let's see. Look at problem number 71. See that graph? See the 71?
Uh-huh.
Is that graph a function or not?
Yes.
Yes, it is. So here we go. It says find g of -4. So they're giving you x, right? So when x is -4, they're asking what is y? What is it?
2.
Right. 72. What's g of 2?
-2.
That's right. Number 73, g of -10. It's
Two.
it's going forever to the left, right?
Mm-hmm.
Forever to the left. So what's g of -10?
2.
Right. What's g of 10?
-2.
Right. So now in 75, it says they want to know the x value now. So now they're giving you the y value. So they're saying when y is 1, what's x?
-2.
When y is 1. When y is 1, what is x?
Would it be -1?
Actually, you're right. Who said, did you guys say -2?
Brandon did.
Yeah.
Yeah, Brandon, that's right. That's right. My bad. I was looking at the wrong graph. That's correct.
Oh, no, that's
Okay,
okay.
let's look at number 76. When y is -1, so find -1 on the y. When y is -1, what is the x value?
1.
That's correct. Okay, does anybody have any questions about problems number 65 to 76? Because we're almost done. And I want you guys to get an A on this test.
Okay.
All right. Number 78. They're saying they want to know when x is -2, what is f of -2? Let's do the whole problem. You got to answer a bunch of parts. You got to answer the domain, range, all kinds of different things. So pay attention and make sure you take good notes. Can you guys see the board okay? Okay, I'm doing problem number 78. They're asking for a whole bunch of stuff. Okay, I'm going to write it down. They're asking for in A, they're asking for the domain. In B, they're asking for the range. And we talked about this the other day, right? Domain are the x values, the range of the y values, or where the graph exists left and right, range is up and down. C, they're asking for the x-intercepts. D, they're asking for the y-intercept. In E, asking you to evaluate the function. Asking you to evaluate f of, in this example, they want you to evaluate f of -2 and f of 2. All right, I'm going to try to draw the graph. So can you give me some points? 3, 0. Can you give me some points, please? Left 3, 0, right 1, 0. No, you're not going to help me.
0,
Left
3.
1, hold on. Left 1 up 4, 0 up what?
Up 3.
Okay, this is good enough. All right, ready? The domain is where the graph exists left and right. These arrows mean it goes down forever, but it also means that it's going forever left and right, right? So what's the domain? And we're going to write it in interval notation. What's the domain? Isn't it all real numbers? So when you write -infinity to infinity, yes, no, somebody say something. You guys get it or not? 78?
Yeah, I get it.
All right. The range is where the graph exists up and down. Now this thing goes forever. So doesn't down forever mean -infinity? So it goes up to what?
To 4.
Up to what?
Up to 4.
Closed.
Yeah.
So remember, the parenthesis means you can't hit it. And close, you do hit it. All right, now, what is the x-intercepts? Now, normally I have students write the intercepts as ordered pairs, but I'm going to show you how they're probably going to write it in the book. So what are the ordered pairs for the x-intercepts? Where is it crossing the x-axis?
What would it be? 3 and 1 and -3.
Left 3, 0, and right 1, 0. So that's how you're going to have to write it for me. I think the way they're going to write it in your book is they're just going to write 3 and 1, something like that. It's very, very poorly written though. But on the test, I think you're going to practice problems and see how they want you to write it. What's the y-intercept? It's also a point, and it's always 0 something. So what's the y-intercept? Where is the graph crossing the y-axis?
3.
At 3.
Right. And they might write it like this. They're going to write that one like x colon. They might write the y-intercept like y colon 3, which is poorly written. So I think this is how your book's going to write it on an exam. I like them written like this because they are points. Okay, so here we go. When x is -2, what's y? When x is -2, what's y? Go ahead, I'm listening.
3.
When x is 2, what's y? Can't really see it on my graph. You have to look on your book. When x is 2, what's the y in your book?
-5.
Yep. All right, do you guys have any questions about this? I can do one more if you want me to. You're going to write your domain and range and interval notation. You're going to find the intercepts are where the graph is crossing the x-axis and the axis. Like I said, your book's probably going to write like that. That's poorly written, but that's how the testers can probably write it. And this is when x is -2, y is 3. It's a fancy way of writing an ordered pair. When x is 2, y is -5. Questions about this?
So so when it's -2, right? It's 3.
When x is
Yeah,
-2,
you're right. But I'm
y is
asking,
3.
how do you get
Right.
that?
When x is 2, y is -5.
Because it's going down.
Yeah.
Okay.
Yeah, it's going left 2, up 3, and it's
Right.
going right 2, down 5.
Oh, okay. I get it now. Okay.
Right? These points are on the graph, right? I'm not upset with you. I'm just really upset with the Algebra 1 teachers. So I'm real upset with them. So I'm not upset with you. All right. Let's do problem number 80. We're gonna do the same thing. And I have 5 minutes. So what did we do? We found the domain. We found the range. What was the next thing we found? The x-intercepts. We found the y-intercept. And then we computed the function values. So they want us to do f of -4 and f of 3. Okay, and I'm going to try to draw the graph and get a new pen. Can you guys help me out with some points, please? Points on the graph. Left 1, 0. I'm listening. Right 1 up 2.
Down 3-0. Wait, never mind.
It's okay.
Uh,
Left, is it left 2 or left
Left 4 up
3?
3. I mean, yeah.
Left 3 up 2? Yes?
Yeah.
Yes? Okay. So let's just go with that. Okay, what's the name? Does this graph go forever left and right, or does it stop?
Forever left and right.
So it's negative infinity to infinity. Okay, what's the range? Well, the graph isn't down here. Where does it start?
at 0.
Closed on 0 up forever, right? Closed on 0 up forever. Okay, what's the x-intercept?
-1, right?
Left 1, 0.
Left 1. Yeah,
And
yeah.
they're going to write it like that, which is poorly written. What's the y-intercept? Zero something.
It's 0-1.
0 up 1, and they're going to write it like that, which is poorly written. Okay, here we go. When x is -4, what's y?
At 3. Wait, is it 3? No.
Yeah, it's 3.
Oh shit.
Watch your language. When x is 3, what's y? Gotta look at your book. When x is
It's
3,
4.
what's y?
4.
Now I want to show you guys something. This is my answer book of worked out solutions, and I want to show you this. How to do transformations. Look at all this work they're wanting you to do. So these are all those tables. Now you guys want to do all this work, or you want to learn how to do transformations?
No, I'll learn transformations.
Crazy, right?
Yep.
And guess what? You're never going to finish any exams if you have to do this. It's too much work. All right. Anybody want to ask me any questions? That is the lesson for 1.2. The assignment,
So, Ms. Birch. So for 80, how? Okay, so
the
for,
assignment
okay.
is due on Thursday at 11:59. Don't wait till the last minute to do it. I'm just saying 11:59 because it's really super late, but you don't wait till the last minute to do the assignment. You turn it in like a day ahead of time, or turn it in the afternoon on Thursday. All right, go ahead, Bernie.
So for part E, you see how it's like -4 and then it goes like =3. So it's always gonna like flip from the second F to the first F. Do you get me? Like so
No.
-4 = 3 and then 3 = 4? No?
Now, I could have said, what is f of 0? So go ahead, what's f of 0?
Wouldn't that be like -1?
F of 0, when x is 0,
Oh.
it's down here.
No.
When x is 0, what's y?
1.
Let's do another one. When x is -3, what's y?
2.
Right.
Oh, okay. This makes sense
So
now.
your x's are running left and right.
Yeah. And
Y's are
then y is
running up
coming
and
back.
down. So these are all, let me read it in red. These are all X's. X, 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 X. And what you're giving me is when X is that number, what is the Y value? What is the Y value? What is the Y value? What is the Y value?
Yeah, for sure. I get it now. I was
And
overthinking it. For sure.
so when you look at this, if I wanted to, if we were doing something different, wouldn't this be left 4 up 3? Wouldn't this be right 3 up 4? Wouldn't that be 0 up 1? So this is a fancy way of writing ordered pairs, and we call it evaluating,
Okay. Yeah. I get
right?
it now. I was just overthinking it for sure.
No, I know. That's why I'm intense right now, because I'm like, this is super easy. Don't make it harder than what it is. But you have to know the X axis and you have to know the Y axis. Right? So X is left or right. So that's why I like you to read it. Left 4 up 3, right 3 up 4, 0 up 1, left 3 up 2. And that's what I want the algebra teachers to teach. I don't want them to teach -4, 3. Nobody understands that. All right, you guys good for the assignment?
Yeah.
All right. Hope you guys have a fabulous day. All right. Have a fabulous day. To the last minute to do the assignment while it's fresh in your mind. Okay. Don't turn it in late.
For sure.
Okay? All right, guys. Have a good day.
Have a good one.
Good job today. Good job. I'll see you soon.